Alright, so lads, if most just put into the calculator root 18, what you're going to get is 3 root 2. Now what I want you guys to understand is the in-between step. Does anybody know the in-between step? What's the in-between step? Root 9 by root 2. And you're always looking to use the numbers 1, 4, 9, 16, 25, all the way up to 100 and onwards. You're looking to use the square numbers. Is that okay? So you get 3 root 2. What about this one here? Root 9 root 5, which would be? Anybody? 3 root 5. And finally root 28. What do you think? Root 7 root 4, which is 2 root 7. Yes? What? Not yet. Just keep staying for a bit longer. Alright. Now, we got this stuff here, right? So we're going to draw. Alright. I might do a Venn diagram to illustrate this, okay? What's the smallest set of numbers you can think of? Huh? N. What's N? N would be 1, 2, 3 upwards. Is that okay with you guys? That's an example of 3 natural numbers. What goes around N? Z will go around that, or Z, if you're getting fancy. Z. Right? And there's your Z. And what does Z contain? It contains all the positive whole numbers, and what else does it contain? All the negative ones as well, like minus 1, minus 3, minus 2. Everybody cool with that? Right. Now what's beyond that again? What does Q do? Q is the rational numbers, okay? And the rational numbers is anything that can be presented as a fraction. 3 would be 3 over 1. That's why it's already inside it. Ever cool with that? These are the numbers like 1.5 and stuff like that, like 3 over 2, minus 3 over 2. Anything you can think of that's not a positive whole number. Okay? So Z is all those numbers. Q is all those numbers. Now what's R? Any number you can think of, ever. Pick a number. It's R. Huh? Somebody say 6. Really got inventive there, you did, alright? So, here's R. Okay? R is any number you can think of. Give me, what about root 3? What's root 3? In the calculator. Go to your calculator. Most numbers can be expressed as a fraction, okay? So if I went minus 3.5. Sorry, yeah. If I went minus 3.5. You see that it expressed the answer as minus 7 over 2. That's a rational number. If I use something like root 3, see the way there's no pattern in the number? And see the way the calculator refuses to put it as a fraction? That means it's a real number, but it's not a rational number. These numbers on the outside are known as what? Can anybody tell me? These are the irrational numbers. They're numbers that cannot be expressed as a fraction. So here we go, right? Here's what it's looking for us to do. Give me an integer that's not a natural number. Example? Anybody?
Minus 6.
Minus 6 and another one? Minus 7. Done. Give me something that is a fraction but not an integer. Minus 7 over 2 and 7 over 2. Minus 3.5 and plus 3.5. Last one. Give me something that's real but not rational. Root 3, root 7, pi, e to the power of 1. E. Let's check it out. Let's go in here and lob in e. See the way there's no real pattern? Try and change it into a fraction. It's having none of that, is it? No good. Go to pi, shift pi. Press pi. Does pi change into a fraction? What about 22 over 7? It's an approximation, it's not exactly pi. 22 over 7 is close to pi, but it's not pi. Everybody cool with that? In fact, if I did pi take away 22 over 7, you can see it's actually quite a small number. It's 0.0001, something like that, okay? Now, happy days. That's what we're doing there. Now, these guys here are quite easy. What can I change root 8 into? Anybody remember? And put your maths up properly in a minute. What can I change root 8 into? Root 4, root 2, which is? And what's 3 times 2 root 2? 6 root 2 plus 5 root 2? Anybody? Now, realistically in a test, you're to know how to do that. But realistically in a test, what are you going to do there? You're just going to throw it all into the calculator because they won't know any difference. And they're never going to say, don't use a calculator. Go on the honesty code here. That doesn't happen. You could do each part individually if you really wanted. What's that? Okay. And then you go 2 root 27. 6 root 3. 3 root 3. Just to prove I can do it, I'm going to use 144, root 144 root 2. And that'll give me minus 12 root 2. So what's your answer there? 2 down, cancel. What do you leave? Minus 3 root 3, okay? Happy enough? It says A, B is an element of Z. A and B are an element of Z. They're minus 3 and plus 3 respectively. Now we get into the fun stuff. Now, before I get into the fun stuff, we're going to go back to the original, we're going to go back to the introduction. I'm going to construct a line of length root 2, and I'm also going to construct a line of length root 3. Everybody cool with this? Now, before we begin, here's the 2 things I need you to be able to do. Does everybody know how to do a perpendicular bisector? Hopefully. You get your compass, alright? And what we do is the following. We pick another length B. Everybody happy with B? I need a line that goes dead centre through AB and perpendicular to the line AB. Everybody cool with that? Get a length and go over halfway. Any length over halfway you want. Everybody cool with that? Do a line up here like so. Change sides. Go back over here. Do another one. And then what do we notice about this line here? When you join the 2 intersections? If I was to rub that out, well, I can't actually rub it out for some reason, but if it was, what would happen? It's a straight line that's exactly halfway between A and B. So did everybody agree that C is the centre of AB? You cool with that? Right. Next thing I want you to understand is this. If I have a length of 1 and a length of 1, like so, it's not exact at the moment. What's the hypotenuse? What's the hypotenuse? Root 2, isn't it? X squared equals 1 squared plus 1 squared. X squared equals x squared equals 2. X equals root 2. Root 2 is roughly 1.414 in your calculator. Everybody cool with that? Next triangle I want you to know off by heart is this one. If this is a length of 2 and this is a length of 1, what's the length of x? You said root 3? Right. Oliver said root 3 because in this case it would be 2 squared equals 1 squared plus x squared. 4 minus 1 equals x squared. X squared equals 3. X equals root 3. Is everybody alright with that? Nothing you didn't know there. Now, I'm going to have to construct this from the start. Okay? So here's what I'm being posed with. Using a compass and a straight edge, construct a line segment of length root 2 on a number line. Number line's the key part. Ever seen number line? We all okay with that? Alright. You do not need to learn off the letters off by heart. Right? I'm going to draw a line. I'm going to say no worries. Point A. you're at 0. Is that alright with you guys? Pick a length, any length of your choice. Doesn't matter really. Any length, doesn't matter. What? Whatever you want. Doesn't matter. It can be that, whatever you want. Right? That's 1. Everybody cool with that? What's the next one up? I'm drawing a number line here, am I? That's 2. We good so far? So you're 1 and you're 2. And is everybody happy that's the number line? What's the goal of my question? Reread your question. What's the goal of this question? I should be able to write root 2 on this number line. Phelan, where would root 2 appear on this number line? At 1.414. So if I go to my calculator, I've successfully done this question when I managed to get 1.414 when I get a straight line that is exactly around here somewhere. You agree with that? Right, let's start off. Step 1, perpendicular bisector. How do we do that again? Anybody care to tell me? Now, one thing I tend to do wrong a lot is see how big my points are. That tends to actually work against me a lot. So I just want to use the red dot and not the black dot if I can help it. Oh, of course I got rid of the red dot. So I'm just going to go back a second. It happens every time I do this. So, yep. Believe it or not, this actually works a lot against you big time. The smaller the dot, the more accurate you're going to be. As someone who constantly makes this mistake, the smaller the dot, the better. Okay? Let's go again. Please don't be like me and make those stupid little errors. See the way you can get the tip of the compass on exactly the right mark? That's what you want to be looking at every time, alright? So when I put in the dots here, they're going to be quite small. They're not going to be large at all, right? Who was that? 1 and 2. Are we cool with that? Now, what did we already rehearse? We already rehearsed the perpendicular bisector, didn't we? Spoilers. Where do you think that perpendicular bisector should go? It's going to go through the 1, isn't it? Right. So it says it's going to go through the 1. I believe it. What mistake did I make there? I didn't go long enough with the other arc, did I? Right, there you go. Everybody cool with that? Now you got to join those two lines together, like so. Everybody happy goes through the 1? Okay. Next thing. What were we aiming for again? You can label these any 2 letters you want that aren't currently in use. What did we say that was? This was B, and that's C. Is that okay? You can label this D and E. No bother. Okay. Next thing. Would everybody agree that A to B is a length of 1? Everybody agree A to B is a length of 1? Okay. How can I get another length of 1 above B? What could I do there? Anybody have any of this? Just measure the length of A to B. Go over to B. Now what happens when B intercepts it? How long will that be? Everybody happy that's the length of 1? So what am I saying about that triangle? This triangle is a 1, 1. And what did we agree earlier? Hypotenuse has to be a length of root 2. What letter am I on now? F. Is that okay with you guys? And what are we going to say about AF? AF is a length of root 2. Have I successfully completed my question? Have I drawn 1.414 on the number line yet? I haven't, have I? Because I've actually drawn 1.414 upwards, like so. Anybody have an idea how to finish that then? Oh, sorry. I'm wrong. That's 1.414. It's the hypotenuse, isn't it? How do I get that down to the number line? Yeah, use your compass and make it into a radius, like so. Whoop. Sorry, tilt it like this. Alright, you go here, you fold it backwards, you go no bother. Everybody cool with that? And finally, what am I on? G now, is it? What do you think the length AG is? AG is definitely root 2, which is 1.414. That's 1.414. You cool with that? Alright. Next one we gotta do is root 3. What triangle did we say we got root 3 out of earlier? Huh? 2, 1, and then that's root 3, wasn't it? Right. Let's start off the same we did last time. What did we do last time, Charlie?
Number 9, 1, 2.
Okay, small dot. That can be A and that can be 0, can't it? Okay. Get your compass. Pick a length. What length do you want?
1.
What? 1. Okay. Any length of your choosing. That's 1, 0. Ever cool with that? Or 1. And this part here. 2. That's another one. Okay. Now, it wants 2 on the hypotenuse. 2 on the hypotenuse, 1 across. I think we're okay here. Okay. Now, we're going to do what we did last time. And this is point B. And this is point C. Everybody cool with that? What is root 3 roughly? 1.73, is it? 1.732. When I do this correctly, how far should I be along? Somewhere around there-ish, is it? That's the goal of my question, to get that exactly correct. So here's what we're going to do. Okay, we're going to do what we did last time. Get the perpendicular bisector. Everybody cool with that? Perpendicular bisector. And marks goes for the construction lines. Okay, so we go 1. No bother. Yeah, just give it a bit of extra. Take a bit of ink. Now, 2. You can do it like this sometimes, where you just mark it above and below, like so. Okay, then I go below. 1. And then 2. So what happens when I draw that line, link the two of those lines together? What is it? It's the perpendicular bisector that goes straight through B. Everybody okay with that? Now, next order of business. And can anybody tell me why I'm extending this upwards? Yeah, the 2 is greater than. Now, here's what we're going to do next. I want 2 to be the hypotenuse, don't I? So, what's the length of 2 look like? I'll get another colour. Green. Right. How long is 2? How do I find that out? From ya to ya. Yeah? You okay with that? Now, what do we do next? Go up and mark it here, don't I? Probably should have used some extra letters here, shouldn't I? D, E, U can B, F. Alright, what's the length of A to F? A to F is 2. What's the length of A to B?
1.
A to B is 1. Therefore, what's the length of B to F?
Root 3.
Is everybody happy that B to F is root 3? Why is it root 3? Because A to F is 2 and A to B is 1. And you'll show Pythagoras' theorem, yeah? Now, what can I do with A to F now? Oh, sorry, not A to F. We need B to F, do we? And B to F is? Root 3. Just give me a second with this. I think only one problem here, okay? The problem here was I actually shouldn't have started the A off at 0. I should have started A off at -1. B would be therefore 0 and C would therefore be, what's C therefore be? 1. So, does everybody see the length B to F, which we all know is root 3? Everybody see B to F, which is root 3? What can I do then? Come up here. Then grab it like so. And then what do I do then? I'll use a different colour. Let's go for purple. Purple. Like so. And what can you tell me? Give it a letter of your choice. G, I suppose, at this stage. Would everybody happy that BG is root 3? Roughly halfway between 1 and 2. Oh, sorry, closer to 2 than to 1. So 1.7. Is that okay with you guys? So this is root 3 or 1.732. Yes? Yep. Any questions so far? Here's what we're going to do. Okay, what did we do last time, Charlie?
1 is 0 1. That's right line.
Yeah. So root 18 is 3 times root 2. We're going to have to draw a line that's 3 times bigger than root 2. It doesn't specify it has to be on the number line. So that to me is a loophole, right? Which means I don't need to draw it all the way down. Pick a letter. Go for A, will we? Right, make sure your point is really small. You got to remember which one you're looking for again. Is it 0 or is it -1 we're starting off with? For root 3 it's -1 and for root 2 it's 0. Okay? You're going to start with 0. Get your compass and do what, lads? What you do with your compass? Pick any length of your choosing. That's 1 and the other one is 2. So B and C, you're 1, you're 2. Alright, what's the next thing we've done every single time? We did the perpendicular bisector every time. So 1, go down here, 2, over here. 1. Perfect. Right? If that works perfectly, what does it do? Huh? Yeah. You cool with that? Yes, sir.
Should you let it equal to like reinstate just because it's free?
I get what you're saying. You could do that. I'm just going to scale it up. I'm just going to get root 2 and then multiply it by, what's it, 3. I'm just going to do 3 times that length. So I'm happy enough not learning any new tricks and just scaling up the old trick. Now, I am probably running a bit tight on space here, so I'm just going to reduce the whole diagram down. Okay. Now, what did we say earlier? What do we want this triangle to be? To get a root 2. What do we want? 1, 1, root 2. So how do I get the other 1? I want from sorry. This can be quite awkward at times, right? Everybody cool with that? So what can I do here? Make it go upwards, and I need to use some new letters, don't I? U or D, U or E, this one is F. What's the length of B to F? B to F is 1. What's A to B? 1. Therefore, what's A to F? Everybody happy with root 2? Okay. A to F is root 2. Now what do I do with that AF thing there? Anybody? A to F, anybody? What do I do? Cross it here, don't I? What layer do you want to call this? G. AG is root 2. Now what's the only thing I have to do from this point onwards now? So 1 sec. Alright. AG is one of them. That's 2 root 2. And this one here is? There we have it, that's 3 root 2. So pick a letter that we haven't used yet. AH equals 3 root 2. Is that okay with you guys? You just do the root 2 proof except 3 times the answer at the end. Is that alright? Now, what else do I have to do here? That's same thing, except you do the root 3 a couple of times. How many questions are in this?